to Agora Math Circle's Senior Beginner Lecture Note video. My name is Joe, and today we are going over decimals and percents. So for decimals, we're going to look over arithmetic with decimals, rounding, decimals and fractions, and finally repeating decimals. And for percents, we're going to look over what is a percent, word problems, and finally percent increase and decrease. So let's start with arithmetic with decimals. So decimal is a non-integer number that is in between two whole numbers. For example, let's look at 45.13. So this number right here, or this decimal, is in between 45 and 46. And the part that's whole is the 45. And then the part that's between 0 and 1 is 0.13. And we separate them by the decimal point. So this right here is a whole number, and this is between 0 and 1. So let's look at how a decimal is broken down. Let's look at 111.1111. So whatever's to the left of the decimal point is all whole numbers, right? And the first digit is in the ones place, the second digit's in the tens place, and the third digit's in the hundreds place. But let's look at whatever's on the right of the decimal point. The first digit is on the 1/10ths place, the second digit 1/100ths place, third digit 1/10,000ths place, and fourth digit is in the 1/100,000ths place, and it keeps going on and on. So notice how for whatever's on the left side of the decimal point, for example 100, we say 100. But then whatever's on the right, for example 1/100th, we say 1/100th. So the th means that it's a fraction, and it's not a whole number. So let's look at addition and subtraction of decimals. So let's look at 13.9 plus 2.37. So the first thing you want to do is you want to align the decimal points. And so you're going to put it top to bottom, and then you're going to add them just like regular numbers. And remember to align the decimal points. So just ignore the decimal points, add them like regular numbers, and then finally drop the decimal point down. And if you see right here, I added a 0 to right next to the 9 because 13.9 and 13.90 mean the same thing. Since there's 0 in this value, it's not going to affect anything. And let's look at this second example, 3 minus 0.027. So first, I'm going to make this 3 into a 3.000 just to make it easier to subtract. And finally, I'm going to do it minus 0.027. And then I'm going to ignore the decimal points and just subtract like I would a regular number. And then I would drop the decimal point all the way down. So at first I got 2.973, then I dropped the decimal point down. So I got 2.973. Now it's really important that you can either say that this is 16.27 or 16 and 27/100ths or 16 and 2/10ths and 7/100ths. Those all work. So next let's look at multiplying and dividing decimals by powers of 10. So when you multiply a decimal by some number 10 to the nth power, then you're going to move the decimal point n places to the right. And when you divide a decimal by 10 to the nth power, you're going to move the decimal point n places to the left. Let's look at these examples. 2.59 times 100. So since we're multiplying by a power of 10, this is 10 squared, 10 squared equals 100, we know that we're going to move the decimal point 2 times because it's 10 squared, and n equals 2. So that means that you're going to go with move the decimal point 2 times. And that means our answer is 259. Next, let's look at this example. 36.7 divided by 1,000. So we are dividing by a power of 10. So we're dividing by 10 to the third power, since it has 3 zeros. So that means that we're going to move the decimal point n places to the left, and n is equals to 3 here, so we move 1, 2, 3. And wherever we have an empty space, that means we're adding a 0. So our answer is going to be 0.0367. And that's our answer. Now let's look at multiplying decimals. So there are 3 steps for multiplying decimals. The first step is to line up the values, not the decimal point. Next, you want to ignore the decimal point and multiply the values, just like the regular numbers. And finally, you want to count the total amount of decimal places and place the decimal point in the answer. So let's look at this example right here. 3.77 times 2.8. The first thing I'm going to do is I'm going to put it top to bottom, and I want to align the values. I'm not going to align the decimal point, I'm going to align the values. Then I'm just going to multiply like the regular numbers and ignore the decimal points. And then finally, I'm going to count the total amount of decimal points, or decimal places, and add it to the answer, or put it in the answer. So we have 2 decimal places here, and we have 1 decimal place here. So that means we're going to move the decimal point 3 places in the answer. So move it 1, 2, 3, and that's how you get the answer. So the answer for 3.77 times 2.8 is 10.556. And the same thing applies for exponents. So for an exponent, for example, 1.7 squared, you're just multiplying 1.7 by 1.7. And then you just apply the same rules and just multiply them top to bottom, align the values, not the decimal points, and then move the decimal point by the total amount of decimal values that you're multiplying by. So next, let's look at dividing decimals. So there are also 3 steps for dividing decimals. For the first step, if you need to, make the divisor a whole number by moving the decimal point n places. So if you move the decimal point n places in the divisor, that means you also have to move the decimal point n places in the dividend. The second step is to put a decimal point directly above the decimal point for the dividend for the answer. And finally, you're going to divide as usual and find the answer. So let's look at this example right here. 6.85 divided by 0.5. And as you can see, the divisor is not a whole number. So we're going to make it a whole number by moving the decimal point 1 place to the right. So we get 0.5 or just 5. And then here we get from 6.85 we move it to 68.5. Then you're going to put your decimal point directly above, right here. And then you're going to divide as usual and then get your answer, 13.7. So now let's look at rounding. So when we round an integer to a power of 10, we approximate our number by the closest number that's a multiple of a power of 10. So if a number is exactly between, for example, 0.5, and it's exactly in between 0 and 1, we round it to the higher number, so 1. So if you look right here, 0.3 rounds to 0, 0.5 rounds to 1, and 0.7 rounds to 1. So everything that's less than 0.5 rounds to the lower number, and everything that's higher than 0.5, and including 0.5, rounds to the higher number. So let's look at this example. Round these numbers to the nearest hundred, 10, tenth, and hundredth. So the general rule of rounding is that you have to look at the hundredths place, or whatever place it's asking, and then look at the number right before it, or the digit right before it, to determine if you're going to round up or down. So for this decimal right here, 367.756, we are going to round it to the nearest hundredth, right? So we look at the hundredths place, and then we look at the digit right before it to see if we're going to go up or down. And first, let's see if it's more than 5 or less than 5. So 6, that means that it's more than 5. That means it's going to round up. So that means that we are going to round 367.756 to 400, because we're going to round to the nearest hundredth. Next, let's look at the tenth. So 367, so look at the 6, and you want to look at the digit before it, see if it's higher than 5, including 5, or lower than 5. And we have 67, so 7 is higher than 5. That means we're going to round up, so that means we go 370. And then right here we're going to go to the tenth, so that means we're going to the decimal places. So the tenth is the first digit right here, and since we look at the number right before it and it's a 5, that means that we round up. So that means we're going to keep all this the same all the way up to the 10th place. So that is going to round up to 8. Then finally we're going to look at the hundredths place, which is right here, and we want to look at the digit right after it. So that's a 6, that means it rounds up. So we get 367.76. Now let's look at our next example, 47.331. So to round to the nearest hundred, we are going to look at the hundredths place, but there's nothing in the hundredths place. So we look at the digit right before it, it's a 4. That's less than 5. That means we round down. But the only way we can round down from 100 is 0. So that's why our answer is 0. Next we're going to look at the tenths place, and right here it's a 4. We look at the digit before it, it's a 7. That means we round up. So that means we go up to 50. And remember, we're going up to a multiple of 10. So next we're going to look at the tenths place. So right here, then we're going to look at the decimal right before it, 3. That's less than 5, round down. So we get 47.3. And finally we're going to look at the hundredths place. So we have 3 and we have a 1. 1 means round down. So that means we get 47.33. So now let's look over decimals and fractions, and converting decimals to fractions. So there are 2 steps to do that. First, you want to put the number over the corresponding place value. So it can be tens, hundreds, thousands, and beyond. Then we're going to simplify. So let's look at this example right here, 2.54. First thing you want to do is break apart the decimal into the whole number portion and the decimal portion. So the whole number portion is the 2. Then we're adding 54 hundredths because there's a 5 in the tens place and a 4 in the hundredths place. So you can say 5 tenths plus 4 hundredths, or you can just say 54 hundredths. Then we're going to turn the whole number into a fraction. So 200 over 100 equals 2. So we're going to do 200 over 100 plus 54 over 100. which equals 254 over 100. Finally, you want to simplify to 127 over 50. Next, we're going to look at converting fractions to decimals. So there are also 2 steps to this. First, you're just going to divide the fraction, how you divide a regular number. And then, if you need more numbers in order to divide, you want to place a decimal point after the whole number, since 5 and 5.00 are the same, and continue to divide. So let's look at this example right here. We want to turn 7/8 into a decimal. So first thing I want to do is divide it. And 7 right here is our dividend, and 8 is our divisor. And see here, our divisor is bigger than our dividend. So in order to keep dividing, we need to add more digits. So to do that, we're going to add a decimal point right here, and then move the decimal point up for the answer. Then we're just going to keep adding zeros and dividing until we get our answer, and we have a remainder of 0. So our answer is 0.875. So the fraction, or decimal form of 7/8 is 0.875. So now let's look at repeating decimals. So repeating decimal is a decimal value that repeats infinitely many times. For example, when we turn 1/3 into decimal form, we get 0.33 repeating infinitely times. So it never stops repeating. So a way we can write that without cramping our hands is by saying 0.3 with a bar on top. The bar means that the 3 is repeating. So we want to convert fractions to repeating decimals, right? For that, all we have to do is just divide, just as we learned before. So you just divide, and then if you find 4 or 5 digits that continue to repeat, then you just put a bar on top. So now we want to convert repeating decimals to fractions. Well, there are 4 steps to this. And let's look at the example right here. We want to convert 0.2 repeating to a fraction. So first, we're going to let x equal 0.2 repeating. Then, we're going to multiply by 10, so the decimal point moves 1 place to the right. So, 10x equals 2.2 bar. So remember, we moved it by 1 by multiplying by 10. And whatever we do to this side, we have to do to this side. So that's why it's 10x equals 2.2 repeating. Next, you want to subtract x from 10x to cancel all the repeating decimals. So, 10x minus x equals 2.2 repeating minus 0.2 repeating, which simplifies to 9x equals 2. Then you're just going to divide by 9, giving us x equals 2 over 9. So you're just going to isolate the variable. So x equals 2 over 9, and 2 over 9 is the fraction. So now let's move on to percents. To begin, what is a percent? Well, percent is a special type of fraction. When we write a percent, we're pretty much writing a fraction with a hidden denominator of 100. Let's look at these examples. When we say 25%, and this is a percent symbol, we're essentially saying 25 over 100, which simplifies to 1/4. And here's another example. When we say 200%, we're saying 200 over 100, which equals 2. So it's just like a fraction, it's a part of a whole. And a way to remember that is that x% equals x over 100. So now let's look at how to convert fractions to percents. So there are also 3 steps to do this. First, you want to convert to decimal form, and we already know how to do that. We just divide the fraction. Then we're going to move the decimal point 2 places to the right. Finally, we're going to add the percent symbol. So let's look at this example right here. We want to turn 3/4 into percent form. So first we're going to divide the fraction, just how we would do it with a regular number. So 3 divided by 4, and I get 0.75. Remember, I moved the decimal point up. Then I'm going to move the decimal point 2 places to the right. So 1, 2, and I get 75%. So next, let's look at writing percents as decimals. So there are 3 steps for this. First, you want to remove the percent symbol. Then you want to place the decimal point where the percent symbol was. Finally, you want to move the decimal point 2 places to the left, not the right, the left. So let's look at this example right here. Let's turn 26% into decimal form. First thing we're going to do, remove the percent symbol right here, 26. Then we're going to move the decimal point 2 places to the left. So since it's just 26, there's a decimal point at the end. And move that 2 places to the left, and we get 0.26 as our answer. Next, let's look at writing decimals as percents. So first, there's only 2 steps for this. First, you want to move the decimal point 2 places to the right. So 2 places to the right here, 2 places to the left here. So you want to move it 2 places to the right, and then you want to add the percent symbol. Really simple. So first, you have your decimal, 0.26, and you're going to move it 2 places to the right. So 1, 2. So you get 26 point, and since it's just 26.0, you can just say 26. And then we add the percent symbol. So we get 26%. So now let's look at the 3 different types of questions you might see with percents. The first is percent of a quantity. So for this, essentially what you're doing is you're multiplying the percent by the quantity. And there are 2 steps for this. First, you want to change the percent that they're giving you into either a fraction or a decimal, whichever is easier for you. Then you want to multiply the fraction or decimal by the quantity that they give you. So here, in this example, it's asking what's 25% of 200? So first thing you're going to do, you know that you're just going to multiply the percentage by the quantity. So turn this percentage into either a fraction or decimal. So 25 over 100 or 0.25. Then multiply it by the quantity that it's giving you. So 200 times 200 times 200, and your answer is 50. The next type of question is what percent of? And for this, they're going to say this number is what percent of this number. So there's only one step for this. You're going to use an equation. So this equation, A over B equals X percent, for what percent of B is A. And when it says what percent, that means we don't know the percent, so that's why we're assigning the variable X. And then what percent of B, B goes on the bottom, is A goes on top. So let's look at this question right here. 40 is what percent of 200? So first of all, looking at the language, we say what percent of 200? Here it says what percent of B. So we know that 200 is B. Put 200 at the bottom. And then the next quantity, 40, we know that's going to be A. So put 40 on top. And then since we know that percents are out of 100, we can just reduce this to 100. So we get 20 over 100. And either we can change this into a decimal and then into a percent, or just say 20%. So 0.2, and then we know that's 20%. So the next type of question is percent of what number? So this also uses an equation, and the equation is A equals B percent of X. For A is B percent of X. So if it says percent of what number, we know that what number means X. So in this example, it says 80 is 20% of what number? So first thing we're going to do is we're going to look at the equation and see which variable goes with which value. So 80 goes with A, and then 20% of what number? So the what number is going to be X, and then 20% is going to be either 0.2 or 1/5, since we can turn it into a fraction or a decimal. And then we're going to isolate the variable, either using this one or this one, whichever is easier, and you get X equals 400. So now let's look at how to solve word problems. There are 4 steps to doing this. First is to read the problem carefully. It's really important. Then you want to convert the words to math. Next, you want to solve the math problem that you created from the words. And finally, you want to write your answer in terms of the problem. Let's look at this example. Steph bought a new computer for $800. Where Steph lives, the sales tax is 7%. That means you pay 7% of whatever you have, or whatever you paid for, as tax. How much sales tax does Steph have to pay for her computer? So first, we want to convert this percent into a decimal, since it's easier to work with decimals. So this is 0.07 in decimal form. And it's asking you to compute the sales tax. So from the quantity that we have, $800, we are saying that 7% is going to be sales tax. So remember, when you're doing this, you multiply it by the percent, or the decimal, right here. So you just do 800 times 0.07, which gives you $56. So you're paying $56 as sales tax. And remember to put the dollars, because that's the unit for this question. It's asking you how much sales tax in dollars. So next example, Rajiv has 4 blue, 5 black, and 6 white shirts. What percent of his shirts are white? So the first thing we want to do is find out how many total shirts he has. So you can just do that by adding them up. 4 plus 5 plus 6, what does that equal? 15. Then you're going to find how many white he has. So of the 15, he has 6. So that's why we say 6 over 15, because of the 15 shirts, 6 of them are white. Then you're just going to divide and find the decimal form, which is 0.4, and then turn that into a percent form, 40%. And that's our answer. So next, let's look at percent increase or decrease. So the first type of problem you can solve is the percent increase or decrease types of problems. So for this, you're going to find n% of x, and then you want to add or subtract this amount to/from x. So you can add to x, or you can subtract from x. Or you can compute 100 plus n% of x for increase, or 100 minus n% of x for decrease. So you can either do 100 plus n%, or you can just do 1 minus, or 1 plus, and the decimal form of the percent, or 1 minus decimal form of the percent of x. So here's an example. We want to do a 30% increase from 400. So 30% increase means that you want to increase 400 by 30% of 400. That means the result has to be bigger than 400. So the first method, what we can do is just multiply by the percent, turn it into decimal, then we get 120, and then you're going to add this to the original 400, which equals 520. Or what you can do is you can just, since you're already multiplying by 1, and then you just add 0.3 right here. since you're just adding the original 400, you're just multiplying by the original 400 by 1, and then adding whatever you get, 0.3 of 400. So you get 400 times 1.03. This means that you keep the 400 and you just add the 0.03 to it. So that gives you 520 immediately. So the next example is a decrease. We want 60% less than 90. So that means our result has to be less than 90. So what we using the first method, we can just do 0.6 times 90, which equals 54, and then subtract that from 90 to get 36. Or what we can do is just immediately do 1 minus 0.6, which gives us 0.4. You just do 90 times 0.4, which equals 36 as our answer. So next, let's look at what percent increase or decrease. So this is asking what percent. So we're trying to find the percent, not the value that's after, but the percent. So there are 2 steps for this. First, we want to compute the amount of increase or decrease. And then we want to write this change as a percent of the original quantity. So let's look at this example right here. We are increasing, or saying that an increase from 100 to 130. So we're increasing by 30. As you see here, from 100 to 130 is just plus 30. So we know that 30 is 30% of 100. We know that's easy because it's just 100. But let's look at these harder ones right here. So we're doing a decrease from 80 to 20. So first, find the difference. So we're doing minus 60 to go from 80 to 20. Then you're going to put this over the original quantity. So from 80, we're starting with 80. So we put 80 at the bottom, and then whatever we're changing by. So we're decreasing by 60, so we put 60 over 80. And what does that equal? 0.75. And we turn that into percent form, which is 75%. So when we say 75%, that means we are decreasing 80 by 75%. And 75% of 80 is equal to 60, and 80 minus 60 is 20. So that's how we can check our answer. Next example is a change from 3.8 to 9.5. First thing, see the difference. So we're adding 5.7. So we're going to put our difference right here, 5.7, over whatever our original quantity was. So from 3.8, 3.8 is our original quantity. So we put 5.7 over 3.8, which equals 1.5. So that means we're increasing this 3.8 by 150%. And then you can do the math to figure out and check your answer. So let's see. 1.5, we do 1.5 plus 1 equals 2.5, then we do 2.5 times 3.8 to get 9.5. So our answer is correct. So now let's look at some word problems to apply what we've learned. Let's look at this first question right here. In 2009, a shoe company sold 15 million pairs of shoes. In 2010, they sold 20% more shoes than 2009. How many pairs of shoes did they sell in 2010? So we've already done a problem just like this. We just have to multiply the original number by the percent increase or decrease. So right here, it looks like it's a percent increase since it says 20% more. And since we have a percent, we want to turn it into a decimal or a fraction, and decimals are easier to work with, so let's do decimal. So we have 20%, what is that in decimal form? 0.2. And then, since we're doing increase, we can just add it to 1. Instead of just doing 100 plus 20% and then turning that into a decimal, we can just do 1 plus 0.2, which gets us 1.2. And then we're going to multiply that by the original number, 15,000. So 15 million. So we do 15 million times 1.2, which will give us 15 million plus the 0.2% increase. So that gives us 18 million. And that's how many shoes were sold in 2010. So next, let's look at example B. In 2005, the population of Cedar Falls was only 16,000. In 2010, the population was 20,000. By what percent did the population increase from 2005 to 2010? So this is a what percent increase problem, and we just did these, right? So first we have to just find the difference, and it looks like it increased by 4,000. So we put the difference, whatever change we got, which is 4,000, over the original quantity. So originally started at 16,000. So we put that, 4,000 over 16,000, and since I know I can reduce that into 4 over 16, which then reduces to 1/4, I can just say 1/4, and I immediately know that 1/4 is 0.25 in decimal form, which is 25% in percent form. So now let's look at our final 3 word problems. For the first one, 500 students at Euclid University took a math exam. 75% of the students passed the exam. Suppose instead only 20% of the students had failed the exam. How many more passing grades would there have been? So first, let's decipher what this problem is saying. It's saying that 75% of the students passed the exam. That means 25% students failed. And for the second one, it says suppose instead only 20% of the students failed. So we're changing from 25% of students failing to 20% of students failing. That means that we're going to change from 75% of students passing to 80%. We're increasing by 5% the pass rate and decreasing the fail rate by 5%. So that's why we can just multiply 5%, or 0.05, by 500, and we get 25. That means we have 25 more students passing and 25 less students failing. Next, let's write 3 times 10 to the 99th percent as a regular number in the form 3 times 10 to the x. So since we know that for percents, all we're doing is removing the decimal point 2 places to the left, then all we're going to do is subtract the amount of zeros that we have by 2. So we go from 3 times 90 times 10 to the 99th power to 3 times 10 to the 97th power, since we're decreasing by 2 decimal places. Then for our final question, we have if 1 cup of milk is added to a 3-cup mixture that is 2/5 flour and 3/4 milk, what percent of the 4-cup mixture is milk? We want to express this answer as a percent rounded to the nearest tenth. So what we're going to do is first find the amount of milk that we have in cups. So first we have 3/5 as the amount of milk that we have. Then we're going to multiply that by the amount of cups that we have. It's a 3-cup mixture. So that means that we have a 9 over 5 cups of milk in our 3-cup mixture. Then we're going to add 1 cup, so that's just 5 over 5, which gives us 14 over 5. So now we have 14 over 5 cups of milk. And 14 over 5 turns into 2.8. So we can divide the 2.8 by 4, since we added a cup, we have a 4-cup mixture. So dividing the 2.8, or the 14 divided by 5, by 4 gives us 0.7. And that means that 70% of our milk is, 70% of our mixture is milk. So remember, it says right here that we want to round the answer to the nearest tenth. So, since we don't have any percent, we can just put a 0.0% as our answer. Since we don't have any tenths and 0 rounds to 0. So we can just do 70.0% as our answer.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramatrical.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end.